Okay, so in the we've now looked at three different Hess's law cycles. Okay, and just to summarize, what I'm using here is R and P. They stand for reactants and products. If you're given the enthalpy of combustion data, the green one, you'd use that energy cycle with your carbon dioxide and water at the bottom. If you're given delta HF values, the red one, you use elements in the standard states as the third thing. And if you're given bond energies, then I will put atoms in the gaseous state at the bottom, 1 arrow going up, 1 arrow going down. So you break it up into the gaseous atoms, build it back up into the products. So you look at the data you're given and you decide which energy cycle to use. And that's the hardest thing, deciding it really. Once you've got your energy cycle, then it's just putting numbers in, which is easy as long as you don't make a mistake. Right, now sometimes they try and occasionally they'll give you a tricky one where it's not obvious what to do. Let's have a look at this one. You've got to calculate the bond energy of methane, of carbon hydrogen in methane. And the data they give you is this looks quite strange, this one here. Right, so you get 1 mole of carbon and you turn it into 1 mole of gaseous atoms. We haven't come across that before, but it's obviously very endothermic because you have to break all those bonds in the graphite, aren't you? All the covalent bonds. Then they give us bond energy of the hydrogen bond in H2. That's not too bad. That's fairly straightforward. And then, so you're thinking, oh, it's going to be what kind of a cycle is it going to be? It's going to be this blue one here with the bond energies. But then they confuse you because look, they're giving you delta HF value for methane. So then you start thinking, well, should I use the red one there? Okay. Now I think what you've got to do is what I would do is I'd write down that what is the equation for the enthalpy of formation of methane. Let's write that down first of all. So what it is you've got the elements in the standard state, which is carbon, solid, plus you need 4 hydrogens, so that's 2H2, that's gas, and it's going to give us methane, CH4 gas. Now we're going to have to use Hess's law here. So what we've got to think of a third thing to put down there and which energy cycle to use. Well, I think the clue here is that we are given bond enthalpies here. So let's put down let's use the bond enthalpy Hess's law triangle. So what I would put down there then is carbon in the gaseous form and 4 hydrogens in the gaseous form. Okay, let's put a box around that, and then let's think about which way the arrows are going to go. Well, here I can just put the arrow going up, and what are we doing there? We are forming 4 times CH bonds, aren't we? Because yeah, methane, don't forget methane obviously is that. So all we're doing there is we're forming 4 carbon hydrogen bonds, and that's what we've got to try and find out. They've asked us to find that out. So that's looking, this energy cycle is looking quite hopeful. It's going to be useful. So we'll leave that there. This one, we're going to have to break all this up into the gases. Right, now do we have any of the values there? Well, we do have the value for the hydrogen. That's you get. So that's going to be 2 times 436, isn't it there? 2 times 436. It's going to be positive because we're breaking those bonds. And then what's happening to the carbon? We are turning the carbon solid into a carbon gas. And if you look, they give us, yeah, that's what's happening here, isn't it? That's 714. So I'm going to put 714 down there. Right, so we know what this is going to be. Let's add all that up together. That's going to give us 1586 positive value, 1586 kilojoules. This is what we've got to try and find out. So let's call that, let's call the CH, let's call that X. So I'm going to rub that out, what that is here with, it's going to be 4X, and it's going to be a minus number because we are forming those bonds. And do we know that what this value is here? Well, we do know that that is the enthalpy of formation of methane, which they're giving us. So yeah, which is enthalpy of formation of methane. It's minus 75. Okay, so what we can say now is, let's call that the yellow one. Let's call that the purple one. So we know that minus 75 is equal to the yellow delta H plus the purple delta H. And we don't have to do anything with signs there because we are following the arrow in each case, following the arrow there, following the arrow there. Okay, so let's put the numbers in. So we get minus 75 is equal to 1586 minus 4x. So we get 4x is equal to 1661. So x is equal to 415 kilojoules per mole. Now that is when you break the bond, isn't it? That's a positive value because I did call this minus value there. But anyway, that is about the right value for the carbon hydrogen bond. I think it's usually quoted as 413. So that's how you would do that one. So it's tricky when they give you one like that. You just got to put down what you do know and maybe cross it out and change your mind. But again, think of those 3 cycles. Which one is it going to be the one that is going to be useful? I'll tell you another main thing they do as well sometimes is occasionally is you'll get a problem, and it's easy, isn't it? If you get delta HC or delta HC, you know which energy cycle to use. It's combustion products. If you're given all delta HF, then you use the elements in the standard states one. Sometimes they'll give you a mixture of delta HC and delta HF, and it can be confusing. And usually when they do that, what they're doing is they're trying to confuse you. If you think about what is delta HF for carbon dioxide, what's the equation for that? Well, it is carbon plus oxygen goes to CO2. And that has a value of minus 900 kilojoules per mole. But what else are we doing there? Instead of think of it as the delta HF of CO2, you could think of that as being the delta H combustion of carbon. That's exactly the same thing as delta HF of CO2. And the other one which they do like that, if you think what is delta H combustion of hydrogen, what's that equal to? Well, when you combust hydrogen, what do you get? You get H2O, you get water. So that is equal to delta HF of H2O. So if you just remember those, they do try and confuse you occasionally by giving you a mixture of delta HC and delta HF data, but really it's because these 2 are interchangeable. So just get them all. Think what is what's most of the data is in the delta HF form and choose that cycle, or is in most of the data in the delta HC form and then use that cycle. Okay.